Good morning, students. Today we will learn the working of binary vapor cycle. That means this is nothing but the one of the vapor power cycle. Today we'll discuss about the working of binary vapor cycle and its derivation. The first of all discuss about the contents regarding this student lecture. In this binary vapor cycle, the contents are two working fluids used, water and mercury. Second, its component, that is the mercury boiler and mercury turbine, steam boiler and steam turbine, condenser and two pumps, and working of binary vapor cycle and derivation of binary vapor cycle. The first of all, we discuss about the what is the main components of this cycle. In this cycle, two working fluids are used in this cycle. This is the cycle is the mercury steam binary vapor cycle. This is the cycle. In this case, what happens is the boiler section. This is the mercury turbine, and this is the steam turbine, and this is the heat exchanger. This is the condenser, and this is the pump. So we'll discuss about the working principle of the binary vapor cycle. In this cycle, two working fluids are used. It consists of boiler, mercury turbine, steam turbine, heat exchanger, and pump. That means in this case, whatever there are the five components are there. Boiler is there, mercury turbine, steam turbine, heat exchanger, and condenser. Pump is already working in this case. Steam turbine. Any power plant we can discuss about the pump is always present and condenser always present is there. In the working of this binary vapor cycle, we discuss the first of all, the mercury boiler heats the mercury into mercury vapors. This is the boiler. What happens? The mercury boiler heats the mercury into mercury vapor in a dry and saturated state. And this is the boiler section in which the mercury boiler is there and steam boiler is there. Therefore, in this section, what happens? The mercury boiler heats the mercury into mercury vapor in a dry and saturated steam. Then there is a mercury vapor expands. There is a mercury vapor expand in the mercury turbine. This is the mercury turbine in which what happens? The mercury vapors are expanded in the mercury turbine and then flow through the heat exchanger and then flow through the heat exchanger. This is heat exchanger. They flow through the heat exchanger where they transfer the heat to the feed water. They transfer the heat to the feed water because in this what happens? The cooling feed water passes through it. Therefore, they transfer the heat to the feed water and convert into steam and then the steam is passed to the steam superheated and then steam boiler. The steam is generated and then enter into the steam turbine. What happens? Where the steam is superheated by the hot flue gases. The steam then expands in the steam turbine. What happens? The steam boiler, the steam is generated here and the steam is superheated and then enter the steam turbine. And this steam turbine, the steam is superheated by the hot flue gases. The steam then expands in the steam turbine. Then discuss about the mercury cycle. Then go to this cycle. This is the TS diagram. This cycle known as the steam cycle, and this is the upper cycle is the mercury cycle. The mercury cycle in the mercury cycle indicated by the A to B, B to C, C to D, D to A. And the steam cycle represented 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 1. Then discuss about the ABCD cycle. The mercury cycle ABCD is a simple ranking cycle using saturated vapor. The heat rejected by the mercury during the condensation process BC. What happens? This is the BC, this is the condenser area. What happens is the heat is rejected. Heat is rejected by mercury during the condensation process B to C, is transferred to boiler and transferred to boil water and forms saturated vapor 5 to 6. And this is what happens. And then case what happens? The from saturated vapor 5 to 6. The saturated vapor is heated the external source furnace in the superheater 6 to 1. The superheated steam expands in the turbine. Superheated steam expands the turbine is then condensed. The condensate is then pumped. Condensate is then pumped to economizer where it is heated till it becomes saturated liquid by outgoing flue gases 4 to 5. The saturated liquid then goes to the mercury condenser. Saturated liquid goes into the mercury Saturated liquid then go to the mercury condenser steam boiler where the latent heat is absorbed. In a in an actual plant, the steam cycle is always regenerative cycle with feed water heating, but for the sake of simplicity, this complication has been omitted. From the TS diagram, we can conclude that how to find out the pump work, how to run the turbine work, about the efficiency of the cycle. We'll discuss about this one. So this is the diagram of TS, and you have to consider what happens in this case. You have to consider m represent the flow rate of mercury in the mercury cycle. Suppose this is cycle. In this case, consider m represent the flow rate of the mercury in the mercury cycle per kg of steam circulating in the steam cycle. Suppose consider Q1. The Q1 means that the heat addition. Q2 means heat rejection. The Q1 means heat addition. Heat addition means Q1 equal to M HA minus HB. HA minus HD. This is the point HA minus HD. The heat addition plus H5 minus H4. H5. H5 minus H4. That again the heat addition takes place in the steam turbine and heat addition takes place in the mercury cycle. You have to add it and you have to Q1 equal to addition of this one. Q1 equal to M bracket HA minus HD plus bracket H5 minus H4. Then discover the heat rejected. The heat rejected takes place in this area, B to C area and 3 to 3 area. That is S2 minus S3. Then turbine work. Turbine work has been done this area. Turbine work A to B region. Turbine work. This is the again 1 to 2 region in the steam turbine. Then turbine work equal to mass of M bracket HA minus HB. HA minus HB plus H1 minus S2. H1 minus S2. Then we already find out the turbine work, then go to find out the pump work. The pump work is the region 3 to 4, 4 to 3, C to C to D and D to C. Then pump work SD minus SC in the mercury cycle and H4 minus S3 in the steam cycle. Then you have to already find out the all values, heat addition, heat rejection, turbine work, pump work. Then you have to find the efficiency of cycle. The efficiency of the binary cycle equal to Q1 minus Q2 upon Q1 equal to WT minus WC upon Q1. And this is the derivation to find out this one of the binary vapor cycle. We will discuss about the another method. You have to find out the derivation of binary vapor cycle. The binary vapor cycle is an attempt to overcome the sum of the shortcomings of water and to approach the ideal working fluid by using the two fluids. This is mostly suitable for the vapor power cycle. So in this cycle, what happens is there is two fluids are used. One is the water and second is the mercury. And then we discuss in this cycle what happens. In this cycle, one is the high temperature region, and other is the low temperature region. Therefore, it is known as the binary vapor cycle. Such an arrangement is known because the one region indicates the high temperature region. That the high temperature region indicated by the mercury, and the low temperature region indicated by the water steam cycle. That is the in this cycle one is high temperature region and other is low temperature region. Such an arrangement is known as the binary vapor cycle. Then discuss about this one. What happens in this case? The binary cycle. The important desirable characteristics of the working fluid suitable for the vapor cycle, because we require the some characteristics and properties. A high critical temperature and a safe maximum pressure. That means it sustain the maximum critical temperature and safe maximum pressure. Low triple point temperature. Triple point temperature should be low. Condenser pressure is not too low. Condenser temperature is not below, that is the condenser pressure is not too below. High enthalpy of vaporization. Enthalpy, high enthalpy of vaporization is considered. High thermal conductivity and it must be readily available, inexpensive, and inert and non-toxic. That means such a cycle can be used where the mercury is available, water is available. Then you have to use the such a type of cycle, the binary vapor cycle. That is the easily available. Then discuss about the TS diagram. What happens? It can be concluded that no single working fluid may be have desirable requirements to working fluid. In this cycle, only one single fluid not essential. It requires maximum two fluids. Therefore, no single working fluid may be desirable records of working cycle. Different working fluids may have different attractive feature in them, but not all. In such a cases, two vapor cycles operating on two different working fluids are put together. One is the high temperature region, other is the low temperature region, and the arrangement is called as the binary vapor cycle. That means the two vapor cycle acting as a two different working fluid together is known as the binary vapor cycle. That means the layout of mercury stream binary vapor as shown in figure. Along with the depiction of TS diagram figure, since mercury having the high critical temperature, mercury temperature is very high, 890 degrees Celsius, very high temperature, and low critical pressure 180 bar, which makes a suitable working fluid which acts as a high temperature cycle, topping cycle. High temperature cycle, high temperature region cycle, the topping cycle, and steam cycle will act as the low temperature cycle. That is steam cycle considered as a low temperature cycle. So in this binary vapor cycle, mercury vapors are generated in the mercury boiler. This is the very important line. The mercury vapors are generated in the boiler. This is the diagram. This is the boiler. This is the mercury region. This is the steam region. The mercury is produced, mercury is generated. Mercury is the generated in the mercury boiler and sent for the expansion in mercury turbine, and sent to mercury turbine expanded in the mercury turbine, expanded the mercury turbine. Then in condenser the water is used for, in condenser the water is used for extracting the heat from mercury so as to condensate the amount of water entering the mercury condenser. The mercury condenser also acts as the steam boiler for superheating of heat liberated during condensation of mercury is too large. To evaporate the water entering of steam, an auxiliary boiler may be employed or superheating may be realized in the mercury boiler itself. From the cycle, we conclude that we have to find out derivation. That way again the steam is generated, uh, mercury vapors are generated in the steam mercury boiler, then enter into the mercury turbine, the steam mercury vapors are expanded and enter into the heat exchanger and repeat once again. And then again in this case what if the steam is generated and steam is separated in the case having a direct fraction equal to 1, enter into the steam turbine and the steam is entered into the condenser section, then again repeat the one cycle. That means from the diagram we can conclude that how to find out the work done. Find out the work done from mercury turbine, work from the steam turbine, pump work, heat supplied. And this is the line given, the work from the mercury turbine. Work from the mercury turbine. It is given with this equation and then put the values, we will get the heat rejected. This is the heat rejected area in this case. This is heat rejected. The heat addition region is A to D. Heat addition is 1 to 5. Heat rejection 2 to 3. C to D. Then turbine A to B 1 to 2. And pump region 4 to 3. C to D. And from this equation you have to put the values. You have to apply the equation, find out the heat supplied, heat rejected, turbine pump, work turbine, pump work, turbine work, and you find efficiency of that one. And this is the end of the today's session of the binary vapor. That is, today we'll discuss about the binary vapor cycle, the discussion about binary vapor cycle, that means the components, and discuss about the components, and we discuss about the working of binary vapor cycle, derivation of binary vapor cycle, and this is the end of the today's session.